All right. This week you are working on finishing everything up, and then this is your end of quarter one exam review, so it contains problems that look very similar to probably your mid-quarter exam, and then what we've done since then, so all of the factoring. So work through this review. You are allowed to use this review as you work through your test, so the more thorough you are with this review and understanding each of the pieces, the better off you'll be as using it for a resource. The review does need to be submitted, as you can see, for the test to unlock, so make sure you review and then submit your review just like you have your homework. Just take a picture of it, and then that will open your exam. The exam will be able to be opened on Thursday and Friday, so it'll be open all day both days. You're welcome to take it either day. Again, you're allowed to use your notes. Just make sure that you have enough time to sit down and take the exam. Also, as you're going through this, there are 3 little questions at the very last problem of this review. If you listen for the mathy jokes in the video and record the answers, then you can get a bonus point on your exam. All right, so I'm going to work through these rather quickly. Hopefully you are kind of already did. There's also the PDF attached if you need it. So first of all, this section, writing in standard form. We've covered a lot about this, and then name the polynomial by its number of terms, state the leading coefficient, and the degree. So remember, standard form means that we take the highest exponent and we let that term go first. Well, that's not the highest exponent. Oops. 5 is the highest exponent here, so 6p to the 5th gets to go first. P squared is the next highest, so the negative 10p, remember that negative stays with its term. And then lastly, 2p. So if we were writing this out, we would write 6p to the 5th minus 10p squared, and then we would put plus 2p. If I'm classifying it by its number of terms, this one has 3 terms, so we would call it a trinomial. Asking for the leading coefficient. Remember, the leading coefficient is the number that leads the polynomial when it's in standard form, so this one would be 6. And then identifying the degree. The degree is the highest exponent, so this highest exponent would be 5. On the next one again, the negative 10a squared. A squared is larger exponent than the negative 3a, so we're going to move that. This one only has 2 terms, so we would call it a binomial, and that leading coefficient out front is negative 10 this time, and its degree, if you look at that highest exponent, is only a 2. Number 3, 4x, there's only 1 term here, so he's already in standard form, and we're looking at a monomial. 4 is that leading coefficient, right? The x is the variable part, 4 is the coefficient. And in this case, it looks like our degree, right, would be 1. There is an x there, even though we don't write the 1 power. We're looking at a degree of 1. Number 4, state the greatest common factor for the expression. So we've practiced a lot with greatest common factors lately, just finding something that divides out of every term. So it looks like 6, 2, and negative 10 are all even numbers that divide by 2. And they all have at least 1p, so we are going to have a greatest common factor of 2p. State the greatest common factor for this expression. Notice here you've got a negative 3 and a negative 10, so we could take out a negative 1 if we wanted, but nothing else divides out of 3 and 10 nicely. So notice they each have an a as well, so we could put negative 1a, or if you would just like to put a, that's also considered greatest common factor. Looking at the next one, which of the following represents the simplified expressions in standard form? This one, notice right between here is subtraction, so we're subtracting these polynomials, meaning we need to distribute the negative, so like negative 2x squared, right? Negative times a negative is positive 7, negative 2x to the 4th, and then we can combine like terms. So if I have 6 right here, and I combine it with this 7, that's going to give me 13, so I know it's either C or D, because they both end with 13. 8x to the 4th and negative 2x to the 4th. 8 minus 2 is 6x to the 4th. So it looks like it's going to be D. So I'm going to mark this one, and then let's just check that middle term. So we've got 8x squared, negative 2x squared. Oh, sorry, that's a negative 8x squared, giving us the negative 10x squared. So yep, that one looks good. So make sure, again, we're good with our subtraction. Graphing absolute value functions. So remember, each of these pieces are transforming it in some way, right? If it's on the end, it's going up 2. If it's on the inside, this guy's going to go right 3. And in the front, that changes the slope, and we call that a stretch or a shrink. So our vertex here comes from these H and K shifts, right? And H is always the opposite of what we think. So this one's actually going to move right 3 and it's going to go up 2. So it's going to be at the point 3, 2. Remember, domain for these is always all real numbers, so negative infinity to infinity. And our range, if you look at this function, you could graph it first, or you can just look out front and see that this 1/2 is positive, right? There's no negative that reflected this. So he's still opening up, and he's at this point, right? Where the y value is 2. You can see that from our vertex. So this guy's from 2 all the way up forever and ever and ever. So we're going 2 to infinity. Or for those of you that like to write y is greater than or equal to 2, that's good too. Transformations, right, this guy's going to shift up 2. It's going to go to the right 3. And then notice the 1/2, because that's between 0 and 1, it's a fraction value, that's going to be a shrink by 1/2. So when we graph this, we're going to graph that vertex right 3 up 2. And it has a slope of 1/2. So we're going to go up 1 over 2 in both directions to create our V shape here. Again, you can graph this on your calculator or on Desmos to double check your answer. Okay, joke number 1. If you have your review printed off, this goes at the bottom. Let's see. For our first joke, we are going to go with, what shape is usually waiting for you inside a Starbucks? It's a line, of course. Everybody loves to go into Starbucks. That's your first one. So punchline is a line. All right, moving on to number 8. If we're looking at this function, again, we're going to kind of go through the same process. Notice this is going to go down 1, and it's going to go to the left 4. So there's our H and our K. So left 4, down 1. Our vertex is going to be at -4, -1. The domain, again, negative infinity to infinity. All real numbers. And then notice there is a negative out front of this one. So this one is reflected. This one is opening down. So when we graph this one, we know that the graph starts here at our y value of -1, and then it's going to go down forever. But because we write intervals least to greatest, we're not going to say -1 down to negative infinity. We're going to say negative infinity up to -1. So we're going to go least to greatest. Or again, if you want to say y is always less than or equal to -1, that works too. Transformations on this one, again, this is going to go right down 1. It's going to go left 4. It's going to reflect, right? We know that it's going to reflect. And then also that 2/3, again, that's a fractional value that's less than 1, so this is going to shrink by 2/3. Make sure we account for all of those pieces that are transforming the function. Then we just graph that, so we go -4, -1, takes us right there, and then we're going to have a slope of 2/3, and remember we're going down, so it's like a slope of -2/3 essentially. So we're going to go down 2 over 3, down 2 over 3, yikes, it's going to go right over here off my graph. You can go by 2s or something if you don't want it to go off your graph. All right, let's do a little bit more, and then I'm going to split this into 2 videos. So solve each equation, then state the sets of the number system to which your solution would belong. This one we're just solving. Remember, we take care of parentheses first, so we're going to distribute that 7. So we've got that 2 still out front, but -7 times 5x is -35x. -7 times -1 is +7. That's a 7. And -25 minus x. Then we try to get all the x's on one side, right? So I'm going to add 35x here and add 35x here, right, because this is our equal sign. We're going down here. We can move things across the equal sign. On the left side, I have a 2 here and a 7, so let's add those and we just get 9. They're on the same side, so we can combine them. And then on the right side, we still have that -25. If I have -1x and I add 35x, then I'm going to have 34x. Keep moving stuff around. We want to move the 25 away from the x term. So if we add 25, we get 34 on the left side. We still have 34x on the right. We divide by 34, and we get x is equal to 1. So x is equal to 1 here. Now remember, 1 belongs to the natural numbers, and if it belongs to the natural numbers, it's also a whole number, which is also an integer, which is rational, which is real, which is complex. All right, continuing on, we're going to solve this one. Again, we've got parentheses, so we distribute on number 8 to get 6x plus 8 on the left. We get negative 2x, and a negative 2 times 4 is a negative 8. So then we move everything around. So let's say we subtract the 8's over here. We get 6x on this side, we get negative 2x, and a negative 8 and a negative 8 make a negative 16. We then add the 2x to both sides. We get 8x is equal to negative 16. We divide by 8. X is equal to negative 2. So in this case, x is equal to negative 2. Negative 2, right, is a negative value, so we don't start its sets until we get to the integers. And then integers belong to the rational, which belong to the real, which belong to the complex. Awesome. All right, you're making a blanket with a fringe border of equal width on each side. As shown in the diagram, the length of the blanket without the fringe is 72 inches. So you can see right here it says 72 inches. Its width before the fringe is added is 48 inches. We're going to write a polynomial that represents perimeter with the fringe and area with the fringe. So let's think about what a polynomial would look like if we add in that fringe. So I'm going to draw my length here just so I can tell what it looks like. And I've got fringe on this left side of length x, and I've got fringe on the right side of length x, and then in between I have 72 inches of blanket. So in essence, I have x, right, plus 72 plus x. So in total, if I'm looking at this side, I really have x plus x is 2x plus the 72 inches. That would be the length of my blanket. And the width follows kind of that same pattern. So it's got fringe on the bottom and it's got fringe up here at the top and 48 inches in between. So in essence, we've got x and x, which again is 2x, and then plus that 48. So when I find the perimeter, remember perimeter is distance around, so I'd do 2x plus 72 plus 2x plus 48 plus 2x plus 72 plus 2x plus 48. So if I'm finding perimeter, I'm just finding the distance around. All right, 2x plus 72 plus, and I'll put them in parentheses just so you can see, there's a length plus that width plus that length, plus that width. And then we're just adding all of these, so we're combining like terms. So we've got 2x plus 2x plus 2x plus 2x is 8x. And we've got 72 plus 48 plus 72 plus 48, which gives us 240. So this is going to be our perimeter. Okay. From there, it's part B is asking us to find area. So if we want to find area, area is length times width. So my length we knew was 2x plus 72 multiplied by the width of 2x plus 48. From there, that's a multiplication problem, so we just FOIL that. So 2x times 2x is 4x squared. 2x times 48 is going to give us 96x. 72 times 2x is 144x. And 72 times 48 is a great number, 3, 4, 5, 6. And then for our final answer, we'll just combine those middle terms. So 96x plus 144x is 240x. And we get 3, 4, 5, 6. This is square inches. Part C asks you to find the perimeter and the area of the blanket when the fringe has a width of 4 inches. So that's like giving us the x value. We know that x is going to equal 4. So really we can just use the polynomials that we built. If I want to find perimeter, I just take that polynomial from part A and I put 4 in for x. When we do that, we get 8 times 4, which is 32, plus 240. That's going to equal 272 inches. So that would be the perimeter around. And then it asks us for the area as well. So we could find the area using, again, the area polynomial we found in part B, or we created. We're going to put 4 in everywhere we'd see an x. So we've got 4 times x squared plus 240 times x. So we put a 4 in plus 3,456. And if you plug that into your calculator or multiply it out by hand, you should end up with 80 square inches. Okay. All right. Number 12 and 13, these deal with linear functions. and it asks us to find the slope, find the y-intercept, and then write the equation of the line in slope-intercept form, which remember is mx plus b, where m is the slope, b is the y-intercept. So again, we find 2 points on the graph that we can tell where they're crossing. So maybe this one are our 2 intercepts. Notice we're looking at rise over run, so it's going to go up 6, it's going to run 3. So 6 over 3, right, would be our slope, but we would simplify that to positive 2. That looks good. Where is it crossing the y-axis? Well, on the y-axis, that dot there is at 6, so we know it's crossing at 6. So we put y is equal to the slope times x plus our y-intercept, which is 6. 13, same idea. Find 2 spots where you can tell that it's crossing. And then we move from left to right. So we're going to go down 3, and we're going to go right 4. And that looks like our slope is going to be rise over run. And it's crossing there at a positive 3 on this y-axis. So our y-intercept is 3, and then we put it together. Slope, negative 3/4 x plus 3. All right, that's it for this video. The next one will cover factoring and solving for the last page.